Good times. Well, we'll go ahead
Oh.
and kick things off because folks are showing up. Linda, you're going to talk about one of my favorite subjects tonight.
Oh, really?
Durable functions. I love durable functions.
All right.
I don't remember how many conversations I've had with you about it, but I have tested the limits of durable functions, and I've broken it a couple times. So I'm looking forward to hearing you talk about it. So everyone out there in Twitch land, welcome. We're glad you could be here with us for Hampton Roads .NET. We'll drop some links here in the chat in a couple of minutes. But if you're interested in speaking to our group, we have slots available for the next 6 months at least. So I'll get up with Drew and we'll get those links out there. We'd love to have you. But today, we only care about Linda. And Linda's going to talk about Azure Durable Functions. So Linda, I will turn everything over to you. Drew and I will get out of your way. And I'll pass questions to you if any pop up.
Okay, cool. All right. I am going to share screen. And all right. Can you see my PowerPoint?
Yes. There we go.
Okay. So hi, everyone. I'm Linda Nichols. I work for Microsoft. I'm on the Cloud Native Global Black Belt team. We're essentially a team of developers, problem solvers. We tend to tackle some of the kind of CNCF related topics and just kind of like new stuff, weird stuff. We get called in for a lot of outliers. But I tend to enjoy everything that's kind of in the serverless space and the integration space. And so those are the topics that I tend to dig deep into. And Kevin was just saying he loved durable functions. I drug my feet for a long time with durable functions because if anybody kind of knows me or has kind of watched my talks, I'm really into like low code, no code. I'm kind of lazy. I don't really like to write a lot of code. And, that's kind of also why I like serverless. I don't want to bother with infrastructure and containers all the time. So I kind of like to take the simplest path. And so with durable functions, I kind of saw it as, code first. This is for, people who just like really can't, let go of their design patterns or something. So I really went into this with this kind of, reluctant viewpoint of not thinking I would care. And kind of as I started using durable functions and digging in, I was like, okay, this solves so many problems and it really simplifies things in its own way. And so I'm going to go into that a little bit. I'm going to kind of start out though, talking about, kind of what is serverless on Azure. I'll go through this pretty quickly. I'm going to make some assumptions that everybody kind of understands what serverless is and maybe serverless on Azure, or at least serverless on AWS, and we can make some comparisons. But essentially, we're looking at, event-driven architectures where we're abstracting away a lot of the servers. Things are more fully managed. You have a pay-as-you-go model, like you're only paying for what you use. You don't have servers sitting out there just running. And the focus is much more on developers and applications and not on infrastructure. So you can really kind of focus on what you're good at, what you like, and not kind of get stuck debugging things on the server side, and fewer wasted resources. Again, you just don't have machines sitting there, waiting for you to do something. They kind of spin down when you're done using them. So this is the Azure serverless ecosystem. Azure Functions is sort of primary there. That's our function as a service offering. Logic Apps, which is a very visual workflow tool. And there's a lot of kind of out-of-the-box connectors with Logic Apps. There's over 400 connectors now. So that really saves you from writing a lot of code because you can use these connectors. And just now at Build, our offering for our single tenant Logic Apps is now GA. So that's pretty exciting because now it runs on the Azure Functions runtime. It gives you that benefit of being able to run anywhere. So that's another topic, but that's pretty cool. And then Event Grid, of course, like our event broker service for, that kind of fits in with this event-driven architecture. And then API management for managing APIs. That's like a fully managed service that has a whole lot of benefits. And here's like sort of the bigger picture too, with our event-driven serverless in the middle, but that sort of interfaces with everything and expands out to all of Azure. These are all marketing slides, but I really like this slide just to sort of understand kind of, serverless being in the middle. There's probably like a Kubernetes marketing slide out there that has Kubernetes in the middle with everything too. So like I said, I mean, functions as a service is really the heart of serverless. It's your building block. Like fast doesn't mean serverless. It's just a piece of it. And really, there's some things that there's requirements of fast, and there's sort of like guidelines. Really, we want our serverless functions to be short-lived, stateless, scalable, single responsibility. We really want them to be very small, almost like nano services. And really, and that's just to keep them performant and keep them scaling. And we're going to kind of talk about state and stateless quite a bit, but this is really kind of for our general functions. We want them to be stateless. And so a little bit more about Azure Functions. This is kind of all the languages that it supports, but really it supports any language because you can kind of bring your own language as well. So there's lots of examples out there for using Go and, I don't know, COBOL or whatever else you want to use. So this is just kind of what's supported out of the box, but there's also other options. And these are sort of like a representation here on the left of kind of the different triggers for triggering an Azure function. And it can be HTTP or a timer or all kinds of other services. You put something on a message on a queue. You can trigger an Azure function through HTTP from a Logic app. So there's lots of options to kind of kick off Azure function. Bindings is something that's really unique to Azure Functions. It's a little bit different if you're used to using other fast tools, but the bindings, kind of similar to the Logic Apps connections in that they just save you a lot of code and a lot of hassle because you're able to use bindings to connect to other services, either as an input, like a trigger, or as an output. And there's even third-party bindings, like Twilio has its own binding, and like RabbitMQ and other things like that. So anyway, it's really flexible. Bindings are really heavily used too within durable functions. Okay, so we talked about sort of the guidelines of functions. So here's some of the limitations. I mean, one thing is that Azure functions by definition are supposed to be short-lived. So, but sometimes you need them to have a longer duration. That's something that people ask all the time, if we're going to increase the duration, or how would they do long-running functions? And durable functions tends to be my answer to that versus letting an Azure function just run for a long time, or make it support something really CPU intensive just on its own, because that just, for me, that just tends to be a code smell or like a design smell. It's difficult to model common problems. So there's a lot of just design patterns that are design patterns because they solve really common problems. And some of those things are very complicated using Azure Functions because then you need some sort of storage, and you need queues, and then you need to manage like a queue, and then kind of know where you are in a workflow if you have lots of functions and queues. And sometimes that can get really hard to debug. And it just gets very complex very quick, even when you have a lot of very small functions. So the solution to that, is durable functions to a lot of these problems. And durable functions, it isn't like a different kind of function. It's not a different service. It's just an extension to Azure Functions. And really, it's very code first. If you're a low code, no code person, and you really you can't code, you don't like to code, this probably isn't for you, because it does involve a lot of coding. There's some cases though where I feel like it eliminates code if you were to do these workflows a different way, like I mentioned, with a lot of functions and queues and whatnot. You could really end up writing a lot of code, like management code. So I do think that it reduces code in general, but it is very code first. It does not currently support Java. It's on the roadmap. PowerShell is brand new as of build. I think it started with C# and then JavaScript next, which is pretty common for a lot of the services. I guess I should say, since this is the .NET group, that all my examples are in JavaScript, kind of as usual. But in the durable functions documentation, there's a lot of examples in C# and Python. Python's also relatively new, like in the last year. And so like the documentation is really, really good for this service. Lots of examples that you can work from. But also, even though, durable functions is kind of making these workflows easier. And I mentioned that you would normally have to use kind of some sort of storage to hold state. You'd have to have some queues to sort of, move data around. That still actually does happen, but durable functions abstracts it away. It does it behind the scenes. And we're going to talk about that a little bit more later. So now we'll kind of go through sort of these really common durable functions patterns. And you can kind of do, a hybrid approach and a little bit of this pattern, a little bit of that pattern. But a lot of these have very popular use cases. Like, for example, the first is sort of function chaining. And that's something that is a total anti-pattern with Azure Functions without the durable functions extension. You don't ever want to have a function calling a function. You're just going to get into trouble really quickly. And even function queue function, you're going to have a hard time managing that once you start to have multiple steps. But this pattern is really if you have many steps that need to happen in a certain order, and you want to maintain that order. And so that's something that durable functions handles really well. The next one is fan out and fan in, where you have several functions that you want to run at the same time. And then after they've completed, you want to do another step at the end, maybe some sort of aggregation. But that aggregation can only really happen after all the other functions are done. And really, Azure Functions does the fan out pretty well. Like, that's pretty easy to do, to just have a bunch of functions running simultaneously. But really, it's the fan in, which is the problem. And that's really where we need durable functions to be able to understand when those other functions are done. There's no way currently to really understand, like, okay, when do they have the other ones completed so I can then execute something else. The third one I have here is HTTP-based async long-running APIs. So this use case is if you have a function, or maybe multiple functions that are really going to be very long-running, but you have an external user that really needs to check status on it, that it needs to know kind of where it is in the process. So like an example here would be order processing. I submit my order, and maybe there's a lot going on to really like fully process that order, but your customer can't just sit there and like look at a spinner on the screen. So what you would do in that case is, you would start off the workflow, it would be running behind the scenes, and then it would immediately though return, from the response, it would be at a 202. So you get a 202 back with a URL that you could then hit as much as you want to get updated status on the on where this function is running. And kind of so to mirror that is the monitoring pattern. So the monitoring is more if you have something like a long running process, and then throughout the process you want to reach out from inside of the workflow and do some sort of check on something external, and then based on the results of that, then you make some decision, maybe call another function, maybe the workflow stops completely. And so an example of this, there's an example I think in the tutorials of kind of like a weather checker where it just continuously runs and it looks for when the weather is good. And when the weather is good, it hits another function and it sends someone a text message or something and says, hey, it's sunny outside, go check your garden. And you can do something like this with a timer trigger in an Azure function. But the problem with that is that it isn't like there's more chance of overlap. Like if you have a trigger that runs every 15 minutes, then that, depending on how long it takes for the next step to run, then it's not going to be as predictable timing wise. Whereas if you have this process that's constantly monitoring, what it does is it doesn't check again. Like let's say your timer is like 15 minutes. It's not going to check until exactly 15 minutes after the first process has ended. So the timing just ends up being a lot more predictable than if you're just using a timer trigger. The next one is human interaction. A use case for this might be like two-factor authentication, or manager approval. So you kick off the workflow and the workflow waits for some sort of interaction from a human, some sort of manual invocation before it can then move on to the next step. And in the meantime, it's just sort of sitting there waiting, essentially. And finally, external events correlation, which is essentially aggregation. So you have lots and lots of, events that have lots of data, and ultimately, like let's say you have lots of functions that are running, and that you, at the end, you ultimately want to persist some data. And so you can do some aggregation within this workflow before you actually persist to the database. And then you don't have lots of different processes running that are like, submitting data at different times. You can do a little bit of aggregation. And I'm going to go into these patterns again and kind of look at some examples. So now durable functions versus logic apps. I have lots of these conversations because there is some overlap. And for me personally, I tend to go logic apps first. If I have a problem I'm trying to solve, I'll kind of say, okay, how can I do this in logic apps first, where it's more like visual and I have the designer. And that's just personal preference because I just am kind of a visual person, and I tend to try to write the least amount of code possible. And I think then I get to a point where I either need to start adding lots of Azure functions to my logic app, or I just, I get to a point where I just feel like I just need to write code, and it needs to be really like testable, and I really need to know where I am in the workflow, and I need to have a little bit more control. And that's when durable functions like really steps in there. So in durable functions is code first versus logic apps being designer first. And that's kind of the first thing you need to look at. If you have a team of, C# developers, and everybody just loves writing code all day long, and they know design patterns, and immediately, they think about, oh, okay, this would be a map reduce, or this would be a monitor, or this would be actor. Like that type of team, it's durable functions all day long. If you have a team that you have a lot of people that are writing no code, or you have a lot of no code, low code people that really need a workflow, then maybe it's logic apps. And then maybe it's a combination of the two, because there's some pretty good patterns there for using logic apps that call durable functions. And I mentioned earlier, there's now a new version of logic apps that uses the Azure Functions runtime. Okay, so I'll go into this in a little bit more in detail. Really, durable functions just has a lot going on. There's a lot to sort of digest. So I'm kind of giving it to you in bite-sized pieces, and some things I'm going to kind of like go deeper, and it'll make more sense when you actually see code. So durable functions, like I said before, like behind the scenes, there are storage queues and tables and blobs. So all of that is there. It's doing kind of what you would do in a perfect world to store state in a workflow like this. But it's completely abstracted away. There's a history table there. It's using event sourcing to keep track of all of the orchestration. And you can look at that history table. We'll do that a little bit later. Or you can also use App Insights to write some queries to kind of look through all of this orchestration as well. So, you can kind of use it for debugging as well. And by default, it uses storage in Azure. If you're using a Windows computer, like you're doing some local development, using a Windows computer, then you can use a storage emulator, and then you can just kind of basically for free do some testing locally. I'm on a Mac, so I just have, kind of a storage instance in Azure that I connect to for running all these things locally. And since, durable functions are portable, just like Azure Functions, you can package them up in a container and run them pretty much anywhere in Kubernetes, or even like an app service. And so because of that, you need the ability to be able to swap out your backend. Your backend is a task hub. And so that task hub can be, it can be storage, or even it can be now, Microsoft SQL Server as of build. So that's in preview. But swappable backends, I think, is about like maybe it came out around about the time of 2.0. So you have some flexibility there. If you totally take functions out of the cloud and you're running it in Kubernetes, then you don't have to then reach back to Azure for storage. And so that's really, I think, interesting too, just depending on your use case, whether you need something to run on-prem or even another cloud. But yeah, I guess to go back to the first bullet point too, durable functions persist a lot. Like all the function parameters, all the different values that go between orchestrators and activity functions, everything that's like, put on a queue, it stores all that, and then you can take a look at it. All right, so we're looking at a company case study today. And so my thought is we're going to look at this company and look at the problems that this company has. This is a very typical mid-90s software company, and they have a development team that's updating software, for the year 2000 switch. There are a bunch of COBOL developers in the 70s and 80s that coded years as 2 digits, and they understand that the bank that they're consulting for is going to have lots of problems if they don't make these software changes. But there's lots of other issues that the company's dealing with that I believe that durable functions can help with. And so they brought in some business consultants to look at company downsizing to kind of save a little bit of money. And I think it's related to a lot of these problems they have. Like I said, employees are working on the weekends, they're working on Saturdays, also Sundays. Some employees have as many as 8 managers, and almost always someone has a case of the Mondays. There's also a severe lack of company resources. There is a problem with the ratio of cake to employee at most events, and it seems that the company only has 1 stapler. There also is a problem with faulty office equipment, and PC load letter. What does that even mean? And obviously, also there's some repetitive tasks in need of automation. I just cracked myself up there at my own joke. So before we get started with durable functions, let's look at the type of functions in durable functions. Probably the heart of durable functions and the most important to talk about first is the orchestrator. And I like to represent the orchestrator with Tom, because Tom takes the specifications from the customer and he takes them to the engineer. And he doesn't even personally take it to the engineer. His secretary gets a fax from the customer and then runs it down to the engineers. But essentially, that's all Tom does is get information and send information. And that's essentially, even though the orchestrator is doing a lot of orchestration, essentially, when you're writing code for an orchestrator, it's really important that the code itself be predictable. So, and I can't stress this enough, because I have seen firsthand what happens when you don't abide by the rules of the orchestrator. I think in our docs, like, this should just be bold and red. But you can't have, random numbers. You can't generate GUIDs. You can't pull the date time. There's some functions kind of within the durable functions tool set to kind of give you those things that you might need, or you just push them off into activity functions, which we'll talk about in a second. But it's very, very important that the orchestrator essentially stay dumb. It just orchestrates. It doesn't do any thinking. It doesn't do any IO. It doesn't do anything that wouldn't be predictable. And that's so that it's able to take those specifications from the customer and send them to the engineer, and that's it. So then we have the activity functions. So the activity functions pretty much do all the work. And there can be one of them that you run lots of times, or there can be multiples that can run at the same time. They can, run in some sort of sequence. But this is where you do all of your randomness. This is where you do all your hard work. This is where you do all your CPU intensive work. But you still kind of obey this idea of, keeping things small, keeping things simple, and keeping things decoupled. And activity functions help you decouple by taking all the complexity that you really desperately want to put in that orchestrator and dividing it out amongst activity functions. And they're essentially, they look just like your normal Azure function, except that they can only be called by an orchestrator. You can't just call an activity function directly. So entity functions, this is a little bit new. I think this is like my Java showing, but I always want to call entity functions like a bean, because it reminds me sort of like a Java bean for some reason, because they're just like these little functions that hold state. And entity functions can be called by a client function, but I think, or created by a client function. But entity functions are like, they kind of hold information throughout the workflow, and you can have lots of them. They just look like a little class that kind of holds some information, and they have their own little API. Like one popular use is kind of a circuit breaker pattern. So like, let's say that you have something like, some sort of messaging system like event hubs, where you're going to have lots of messages going to lots of functions. And you could run into a problem where if your functions start airing out, you need to set off alarm bells really quickly. And so durable functions is really good for helping sort of monitor the entire workflow that's going on with multiple functions. So you can kind of have an entity function that's kind of like a little stoplight that turns red or green, kind of depending on sort of the health of the entire workflow. There's a lot more to entity functions and kind of the actor pattern. I'm not really going to go into that because there's already enough complexity kind of with durable functions. I don't want to overload people. So the client function is sort of the welcome function, and client functions are responsible for starting an orchestrator or creating an instance of entity functions, and pretty much any Azure function except an orchestrator can be a client function. So I think it's really popular to have an HTTP trigger for at least testing purposes, but it can be any trigger really. And your client function, it doesn't have the same rules as your orchestrator, where it has to be deterministic. It can really just look like a normal function, but it creates this instance of a orchestrator. It starts your orchestration. So hey, durable functions, what's happening? So what's actually going on under the covers here? And so this is what I've been kind of hinting at kind of throughout this so far, and now I'm just going to talk about it. So under the covers, there are storage queues and blobs that are abstracted away from you. I've already said that, and that kind of takes away some of the complication. But what the orchestrator actually does is, and you'll see in the code, it looks like it's calling a bunch of functions, but it's actually scheduling these activity functions. And it adds a message in the queue, which actually schedules the activities. And once the activity is scheduled, then it stops, it spins down. And that's kind of how this stays serverless, because you're only paying for this orchestrator when it's running. And so when it kind of scales back down to 0, then you're not paying for it. And then once that activity is done, the activity sends a response back via queue, the orchestrator spins back up. Now, when it spins back up, it doesn't just spin back up in the middle. It spins back up and it goes straight to the top of the file. And how it knows what to do is it looks then at the history table, which is in storage, and kind of looks through and says, okay, did I do activity 1? Did I do activity 2? Okay, all right. And then it goes down to wherever it was when it scaled back down to 0. and then does some more work. And so that's kind of like, that's how that table history is really valuable for sort of, knowing where we are within this this orchestration. And so that's kind of because of that, if you need to redeploy or something, then that's why you would want to kind of wait for the orchestration to complete before you redeploy, or you redeploy with a different task hub, so that you can then start the orchestration with a brand new history, and you don't then kind of poison the old history. So you kind of do have to have a little bit of respect for what it's doing there. And this is why it needs the code to be predictable, because it needs to understand where it is. And if you have a bunch of unpredictable results coming back, then it can kind of lose track. And I've seen it happen. I've seen for the fan out, fan in, I've seen it just not happen. It just happens sequentially. And then someone will say, well, I don't understand why it doesn't work. And then I look at the code and there's some sort of IO call or some sort of like reading from a file or something that should absolutely be an activity. And if you look then at the history table, you'll see where it will flag something as, okay, this code isn't deterministic, and then it will just it'll do its best, but it's not going to be what you think is going to happen necessarily. So I'm going to go back through these patterns and sort of look at them from an Initech perspective and how we would then solve some of these office scenarios. So, and I guess let me pause there. Kevin, is there any questions so far?
That is a negative.
All right. Okay. Well, hopefully that just means everyone's kind of digesting and not that I've just thrown way too much information.
They're absorbing all your information. You're good.
All right. So I'm thinking about Tom's jump to conclusions, Matt. And I was kind of thinking of it as like sequential, like, you jump again, then you do one step back, then you do yes, and I'm doing the order of the blocks that he has on the mat. And so this is my use case kind of for function chaining here. And in my code, I would just call each one of these. I'd have an activity function for conclusions, and I would just call it in order with each one of these options, and they would all, happen in this exact order. Another use case for this would be like a typical Peter workday. Peter comes into work 15 minutes late, uses the side door so Lundberg doesn't see him, goes to his desk, he spaces out for an hour, then he goes to lunch, then he spaces out for another hour. And then at the end of the day, he knows that he only really, does about 15 minutes worth of work. And that's sort of the aggregation at the end of this function chaining. So after all the steps are complete, then we could do a little math and figure out like, okay, yeah, he only really worked 15 minutes out of the day. So next one is the fan out, fan in. And this is sort of the money laundering scheme that the developers have come up with, where every time the bank does a transaction, it rounds up to the next cent. So it leaves all these fractions of pennies on the table. So in this case, we could use the fan out, fan in, where each one of those, for each one of those bank transactions, we could, kind of run a little utility that sort of takes those fractions of a cent, and we can kind of collect them all. And once it's all done, then at the end, we aggregate all the money together and we do, we add it to our account. And then, of course, if we don't write unit tests, we have a bug, then at the end, we have $300,000 in the account, and that's very bad. So the next one is async HTTP APIs. So the idea here is you have a long running process and someone that needs to check on this process while it's long running. So our client function here is Lundberg, who is our manager. Our manager kind of starts the process, which is essentially telling Peter to do some work, get to work on those TPS reports. So Peter starts his work on the TPS reports, and it's a long running action. It's going to take all day pretty much, even if it's only 15 minutes of that is going to be towards TPS reports. But the Bobs, they may need to get status on what Peter's doing. They may need to call him into a meeting. So the Bobs then basically the client function then starts the orchestrator. The orchestrator then schedules Peter to do work. He's doing work, but then as soon as that initial response comes in, Lumber gets a 202 back and then a link to check status, which then the Bobs can hit to find out where Peter is within his workday. So our next pattern is monitoring. So in this case, we've got a very disgruntled employee who is threatening to burn down the building anytime, his desk is moved or someone takes his stapler. And we need to also consider a fire suppression system should he actually burn down the building. So we have a monitoring system here where every so often, maybe every 15 minutes or so, we kind of do a little bit of a check on Milton and kind of see how he's feeling. Like, has his desk been moved? Did someone not give him any cake? And then depending on his feeling, then it may trigger the building burning, and then another function made for the fire suppression system. Or if he's feeling okay, we just continue the monitor, and it just continues and continues. And it's really not that this orchestrator is just running and running forever, because it still sort of follows that pattern where when it schedules these activity functions, like an activity of every 15 minutes when it does that check, it's still kind of spinning down and spinning back up again. And there's not a lot of latency. There's some, sort of server actions happening behind the scenes that I don't, quite know about. But it still kind of remains serverless, even though you're thinking, okay, well, this is just sitting here on a server. It's still behaving like a typical serverless function. So then we have the human interaction. So here we have, Peter is saying that every day is the worst day of his life. So he goes to the hypnotherapist. And the hypnotherapist hypnotizes him. And the only way to break out of the hypnosis and move along with his normal life is with a snap of the therapist's fingers. And once the therapist snaps his fingers, then Peter can go about his life. However, in our real life case, the therapist dies of a heart attack. He can't snap his fingers, and therefore this process is just continuing to wait. So, and finally, an aggregator. So this is our flare aggregator, where, our boss here needs to check on the flare to see if you have 15 minimum pieces of flare, or perhaps you have 37 pieces of flare, like Brian. So this aggregator looks at all the various flare pieces that are coming in. And instead of looking at each piece of flare individually, he's looking at them all as a big group and aggregating them, and then doing some sort of persistence. So that's how I, just some ideas there of how maybe I might solve some of the problems. So I created some demos here. This is my GitHub. Initech software is my repo where I have pushed up a couple scenarios. And so I'm going to demonstrate kind of function chaining and also fan in, fan out. All right, so I'm here in VS Code. As soon as I figure out where my mouse is, you can see it highlighting here somewhere. This is the bad part about dark mode and also presenting. So here I've got, Kevin, can you see this code? Is this sort of big enough?
Yeah, it looks fine to me. Chad, if you feel differently, say something.
Okay. So here I have, so I'm going to start with this jump to conclusions scenario. And so this is kind of what my client function looks like here. So first of all, I want to note that a lot of this is kind of done for demo purposes. Right now I've got Initech software is my folder. It's also a function app. If you're not familiar with Azure Functions, a function app is many functions running inside of it. And basically you decide how many functions are going to be in an app based on maybe some sort of, correlation between the functions. Or if you have some that are very CPU intensive, then you may want to run them by themselves or with just one other function. In my case, I definitely prefer to have like one orchestration per function app, but you don't have to do that. But each function app is going to have one task hub defined. So if you have multiple orchestrations in a function app, then they're going to share the same task hub, and then it might get a little muddy. Here I'm doing that just because, for the sake of demoing and sort of showing, it just made it easier. But normally I would just have, a different function app for each one of these workflows. So I've got sort of the jump to conclusions, and then my TPS report uploader kind of in the same area here. Still haven't fully figured out where my mouse is, so that's why I'm kind of moving around, but that's only going to be a problem. Oh, here we go. Cool. All right. So here is my Orchestrator. And here it looks like I'm calling these activities, but really that generator, that yield keyword, I'm actually just scheduling all of these. And by just pushing them like this and then returning it, it's going to call each one of these exactly in order. And now this activity is the jump activity, which is here. And this jump activity is super simple. It just takes the conclusion and it jumps to it. And that's about as simple as you can go. Now, while we are in the code here, I'm just going to go ahead and look at my TPS orchestrator. So this is a fan out, fan in pattern here. I always want to say that opposite. I always want to say in and then out, but out and then in. And so what I'm doing here is I am simultaneously uploading a bunch of TPS reports to storage. And then when I upload them, I'm also making sure that I add that cover sheet, which is really important. And then in the end, after they're all completed, then I send a memo to Lumberg to tell him that the TPS report's been uploaded and that there is a cover sheet. And so you can kind of see here where this is a little bit different because these are all running simultaneously. So there's no yield keyword. These are all just kind of put into this tasks array. And then we do this task.all, which is sort of like a promise.all, if that's kind of what you're used to. And this is kind of the down, when I get down here, I'm also calculating the total bytes. If this looks familiar to you, I took the examples for the function chaining and the fan out, fan in from the Azure docs, and then I just sort of adjusted them to be what I needed them to be for Initech, which is, what we do as developers anyway, a little bit of borrowing. So here I get the total bytes. And so I might want to say too that, like, I don't want to, maybe in my memo, for one of my, additions to this, and I might say like, okay, I want to send Lumberg the total number of bytes so he can figure out if there's a cover sheet or not without looking. And so the activity here, check TPS activity, is kind of where it goes out and grabs these local TPS reports. I've actually got them here in the repo, so I can just run this locally. Here they all are without the cover sheet currently. The TPS uploader start is my HTTP client. It's pretty similar to the jump to conclusions one. Let's see here. Check TPS activity. So here I'm just doing some, file logic here to sort of pull in those local files. And so this is the kind of stuff that you could never, ever do in your orchestrator. It has to be in an activity function. So this is like one kind of good example here, and I've got a little bit of error handling. And then I've got my add TPS cover sheet. So this is where I go through, I'm creating this blob service. This is like really badly nested JavaScript, but again, I'm kind of taking the example and kind of adding on to it. So of course, maybe some refactoring here would make this a little bit more async awaiting. But here is, down in here, we once we create a new folder in our blob storage, then we add our TPS report, and then we create a cover sheet, and we add this here. And then we're done. Let me go back to the TPS orchestrator here. And then finally, the last thing is that we send this memo to Lumberg. Kevin, any questions yet I'm kind of jumping all over the place. I'll take silence as no questions. All right, so let me go ahead and make this full screen. So I'm going to run all this locally. I'm actually not going to go in my Azure portal at all. I'm going to run all these locally, and I'm going to use storage that is in Azure, and then I'll use the viewer to look at storage. So now I'm using the Azure Functions core tools. It lets me do this locally. You can ignore this message. This is sort of like just something that happens because I'm on a new Mac version, but this is going to go away, I think, shortly. So when you run func start within a function app, it actually starts all the functions within there. So it's actually starting both of my orchestrations here. But we're going to kind of look at them one at a time, but they're both sort of ready to go. And so these are the two HTTP starts. They give you these two URLs. Within the function.json for each one of these, I kind of changed it a little bit so they're not exactly the same, because it doesn't, like, cause some overlap. And like I said, that would be, if I actually divided them up into function apps like I should have, then I wouldn't have to necessarily worry about that. So now that this is started, let me go back to, I'm gonna have to find my mouse again. There we go. Here's the GitHub repo. I've also got a link here to the Azure Durable Functions docs. I would highly recommend looking through these docs when you're ready to kind of get started here. All right, so let's look at the conclusions orchestrator first. When you call that URL that we just saw in the logs, this is what you get back. This is the ID of the orchestrator. There's also lots of other little cool URLs in here, which is essentially an API where you can get some information back on the status of your workflow. You can also terminate it. You can clear the history. You can kind of do some cool stuff there. But basically, I just started it. I go back to VS Code, and everything ran. So all of these logs here are essentially, you can see where it's calling the jump activity, and it's going through each one of these various items. And then all the way at the end, they're all aggregated together, and it shows that they all happened in order. So now I'm going to go to Storage Explorer here. So this is my storage account that's in Azure. I just kind of used one that I already had and kind of cleared it out. I'm so lazy. And I've got some blob containers in here. There's queues. These queues are all empty currently, but I have these tables here, and I have this history table. And this table is the one that's kind of most interesting to us here to understand kind of what's happened. And some of these might be ones that I did earlier too, but you can see where the orchestrator was started, execution started, a task was scheduled, the orchestrator completed, then it started up again. So this is a lot of really good information. There's execution IDs for all of these. If there's an input or like this name input, it logs all of this. This is pretty good for debugging. I wouldn't want to use this in production necessarily, just open it up in production and look at it. That's when I would sort of rely a little bit more on app insights. But for debugging, kind of here, I go through and sort of glance through this. And like when I was debugging this earlier, I saw where it gave me an error on one of my orchestrators, and I had to go in and change some code. And kind of, I can see that here that I have two different orchestrator instances currently. All right, so let me go back to VS Code here. Actually, let me go back here. And now I'm going to start my TPS orchestrator. So I just started that. I have a new ID. And then I'll go back to VS Code, and we will now look at the logs for this one. So again, it's looping through each one of those files that we found in our directory, and it's uploading them and adding a cover sheet. Now, it's not necessarily going to do them in the exact order that we would expect maybe in the folder, because there's no guarantees of orders when you do fan out and then fan in. But it goes through each time. It's looking in the TPS reports directory at how many it has. It's adding the cover sheet. There's more logs. And then finally here at the end, it's in a memo to Lumberg. So for this one, there's another extra little cool blob here called TPS reports. And so this is a folder. I have like a GUID generator, and I'm creating like a different ID here for each one of these folders. And then as you can see, there's Michael Bolton's TPS report, and then it added the cover sheet there and uploaded it to storage. Same thing for tables. For some reason, I'm just like struggling to figure out where the heck my mouse is today. Here we go. This way, mouse. Okay. All right. And again, with the history, we've now got a couple pages here. But you can see again, this is Lumberg's memo. I'm on page 2 here, but all this information in this history channel for this orchestration that just completed. This is super handy if you've got something that's really much more complicated than what we're tackling right now. All right, cool. So that is pretty much it for the demo. Let me go back to PowerPoint here. Hopefully people are submitting questions. If not, this is just going to be Kevin asking me questions. But I put some resources in here. There's a lot more. There's some really good videos on YouTube. I really recommend Azure Functions University for anything Azure Functions related. Mark just does a really good job. There's a really good module there on durable functions. That GitHub repo there, it just has a lot of samples in it that are, from the Azure Functions team. And just really the docs are all really good. So I am going to stop sharing and come back to StreamYard. And Kevin?
Hey. That
what questions do we have?
No questions. Our friend Coding Campbell was saying he didn't know that Azure had all that local stuff. Local dev with Azure is awesome.
Yeah, it really is. Yeah. So I think the philosophy at Microsoft is really like, we meet you where you are. And I think that's really true. So it's like, oh, you want to use AWS? Well, how about we containerize your functions and you run them on AWS?
Yep.
And then we'll give you a dashboard where you can look at it. So yeah, and there's a lot of local stuff. And really, I mean, because I'm on a Mac, I don't have that storage emulator. I don't know why Mac doesn't have one. I'll just file that under my issue of why can't I use Power BI on Mac.
Can you use what's the new one? Netherite?
Yeah,
because that's Docker. That's all Docker, isn't it? Yeah.
Yeah, and that's totally brand new, but it is public preview. So yeah, anybody can use that. I really have not messed around with my task hubs. I mean, I rename them, but I haven't really tried to swap out any backends. I'm pretty happy just using storage. But I also have a lot of Azure credits, so I'm not trying to sort of count the pennies.
And it's storage, so unless you try, storage is not going to cost you anything.
Yeah.
I have one customer where storage hit like $15. I went, whoa, what was I doing to accumulate $15 worth of storage? And it was a mistake on my part.
Yeah.
So one of the One of the things I like about durable functions, I don't remember if you touched on this earlier, is that traditional Azure functions have a 5-minute limit on them.
Mm-hmm.
And so that's because I had use cases where I wanted to do serverless, I wanted to do functions, but I couldn't guarantee I could get the task done in 5 minutes. And it's like one task.
Mm-hmm.
So I ended up going to durable functions because using your, I don't remember which pattern you called it, but where basically you kick it off and you return the 202, or no,
Yeah,
201. You say, I've accepted this.
Yeah,
Come back
202.
later.
Mm-hmm.
And when you do that, you have a much longer timeout. And
Yeah.
I don't remember what that timeout is, but it's much more time, and you can actually get your work done and you can complete. And I combine that with a Logic app, because Logic apps will natively go back and check for completeness or completion.
Yeah, that's one really great thing about Logic apps, and that's kind of why there are a lot of questions of should I use one or the other. Jeff Holland has a really good blog about the pattern you're talking about using Logic apps to call durable functions. I was watching some random talk of his recently, and he mentioned it, and I was like, oh right, I forgot about that, you know. And I looked back at his blog. So Jeff Holland is sort of like head of applications, I think now, but he was in the Azure Functions team, and he was previously in the Logic Apps team. So his talks are great because he sort of like talks about everything. He likes it all.
Yeah.
So it's nice, and how to use each thing with each other.
It was really nice in that case, because I was like, is Azure Logic App smart enough to pick up on this? And yes, it was. It took off, and it just worked. I'm in the process now with a lot of apps where I started as Logic apps, but now I have to turn them all into functions or durable functions, because the Logic apps execute so often for so long, they're costing me more money than they should. So I'm writing code to turn them back into functions, just because you can have an Azure function run for forever and it won't cost you much. A Logic app will cost you if it runs for a significant amount of time.
Yeah, and I think the new version of Logic apps, the single tenant, is going to help you with that cost, but that's sort of a different topic. I really like the monitor pattern, and that was one that I didn't think that I needed. But like even for, I was kind of mentioning during the talk, like even like a bot, like a Twitter bot or something. Your Twitter bot is almost never exactly every hour, because that function takes time to run. So the trigger is every hour, but it's not very predictable. So if you definitely want to see the result every certain period of time, it's just a little bit more predictable to do it in the workflow.
Yeah. We did have a question come in. This is from Freelance Word, local gentleman. Can you make a full REST API with durable functions?
I guess, but I wouldn't. I would use API management with either functions or Logic apps on the back end, because I think that would be easier. It kind of depends on what your REST API is doing and returning. I guess if there's a lot of like processing on the back end, then maybe like each endpoint might need to be its own durable orchestration. But I haven't come across anything that's quite that complicated for an API.
Yeah.
It's more like a processing system. But API management with functions is great. I use API management with Logic apps a lot to sort of return APIs, because sometimes I will pull in data and then want to like process it and then return it, but it'll just be something simple.
Can I talk about how I've broken durable functions?
Yeah, I was waiting for that. Yeah.
I had a process where we would upload a file to blob storage. I was testing this theory. So upload a file to blob storage. I would have my trigger kick off, and it would read. It was a CSV, and it would parse every row, and it would take the object and say, "All right, durable function, I want you to go process this entity in the CSV." I had 2 million rows in that CSV file. That broke my durable function. Eventually, I forgot what the error is. It's like, no, you can't execute that many durable functions. Because I was trying to do fan out. I'm like, go do all this work and then come back when you're done. And it's
but
like,
you're still you were still in the consumption tier, right? So you're in the cheap, you're in the cheap seats. So I am gonna say, like, at some point, you're gonna have to start paying money to do things that are super, super intensive, I think.
That's fine. You don't mind.
Or change the pattern. Yeah.
I just want to execute, process 2 million rows of data in like 5 seconds. That's just, I want an entire Azure data center to like get hot, do my work, and then come down. That's all I want. And so yeah, it gave me a error message. I went, crap. All right, back to the drawing board. So we didn't solve the problem that way. But it would have been nice.
I do feel like, though, I mean, I don't know. I feel like it should not, that shouldn't have necessarily broken it. But I do, there are limits. At some point, like, you know, the server people have to eat, and so you have to give them more than pennies.
I think I tried another approach where I was batching it. So for each individual task, it wasn't process 1. It was like process these 100 and tell me when you're done. But still, like, there was a theoretical limit I was getting close to hitting. We ended up re-architecting it to just put stuff into a queue and say, all right, well, it turned out to be more performant to just throw everything in a queue and let a native Azure function queue trigger go off and just run through that queue as quick as possible.
Yeah, I mean, that makes sense.
Yeah, wasn't as nice as the durable function. Like, would have been nice to just have everything come back at the end. And because the problem with the queue method is, how do I know when I'm done?
Exactly.
I have to ask every queue function to say, all right, well, go check the queue and tell me if there's anything else in there. If there's not, then go do this other thing, which isn't ideal. I'd rather.
I would like to, like, play around with that and, like, sort of make some adjustments to sort of like the, you know, the settings in like host.json or something, and see if we could figure out what broke, or, you know.
I could set that back up again.
Because I'm curious. I kind of feel like it shouldn't have broken, but I don't know. Maybe this was just completely.
Yeah, I don't remember if it broke locally, if it only broke when I pushed it up to Azure. That I don't remember. I can set that demo up again and then, like, throw 2 million rows at it just to see what happens.
Yeah, that'd be cool.
But it was a lot. So.
Something I didn't mention also in the demo, but you can tell if you look at my GitHub repo. I do have a GitHub action there that's deploying whenever I push, and so that was super easy. I just sort of intentionally tried to see if I could do this demo without ever having to go to my Azure portal.
Yeah.
Where I've got tons of crap up there. So, but really, though, you can just go to the deployment center within your app, and then you can it's really easy to set up a GitHub action. It actually creates it for you. It commits it to your repo, and then I made no changes to it. I was like, okay, this looks good. I added a linter because I'm like crazy about linting. And so I added that, and then I just, I pushed it up, and so now I have a CI/CD for durable functions, because they're essentially just still functions in a function app. So
good time.
Usually I get a DevOps question. So
I know chat has been quiet today, but we've had some good people watching. So that's well, folks, if you don't have any other questions, I'm going to let Linda have the rest of her evening. Yes. And Drew too. I mean, Drew.
You have to go check my garden while it's still light out.
Well, you got plenty of time. You got at least another hour and a half of daylight. But alrighty, folks. Well, thank you all so much for hanging out with us. Thank you, Linda, for a great presentation. I remember reading the title and going, Office Space. I hope she's talking Office Space. I'm pretty sure she's talking Office Space.
I can answer any Office Space questions. I know so much about Office Space. I mean, you can tell I'm sort of at obsession level. I mean, I guess I will say before we leave, this whole talk idea came from the Orchestrator, because I was helping someone who put too much in the Orchestrator. And I was trying to explain to them, no, it has to be really dumb. It just takes something and it passes it along, and it just schedules, and that's all it does. It's just really like a dumb manager. And I was like, oh, it's kind of like Tom. And then I started thinking more and more and more. And then I was talking to my coworker, and then I was kind of like, what about when Nita answers the phone and it's really repetitive? And, what about a switchboard system for Initech? And so in the GitHub repo, I started putting a bunch of to-dos in there for future apps. So I'm going to create demos in there for all of the kind of pattern scenarios, and including durable entities. So, watch this space.
That's awesome. And they fit so naturally. It's not even like you had to force it. It's like, no, that makes perfect sense.
Yep. Yeah.
So good job. Yeah, that was awesome.
Thanks.
Alrighty. So folks who didn't see it before, Drew threw up the chat for if you want to sign up to speak in the future. We can't have Linda every month, so we have to
every other month and Kevin in between.
Yeah. So Drew will take 1 month, I'll take a month, and we'll have Linda back. That'll be our repeat. But if you like to speak, it's all online. You don't actually have to leave your house or basement or wherever you are. We would love to have you. Drew put it up again in chat. So, all right, folks. Well, we will see you all next time. Thanks, and have a great rest of your week.
Have a good evening.